session, we are going to talk about array rotation. We will first understand what do we mean by array rotation, and then we will see various approaches to rotate an array. So let's say we have this particular array with us, and the rotation could be either left rotation or right rotation. So let's talk about left rotation. So left rotation is something which happens in this particular direction, and right rotation happens in this particular direction. So here we are talking about left rotation. So what happens if we rotate this particular array? So before we go on to rotate this array, we have to know that we are rotating the array by one place, two place, three place. What is it? So let's say we are rotating the array by two places. So in that case, what will happen is that when we rotate the array, simply if this is your array and we have to rotate it, let's say the new array is kept in this particular place. So what will happen in the rotation? So this 3, 4, 5, 6 will come two places ahead, and now what will happen to 1 and 2? So if you think of this as a closed loop, what will happen is that through this loop 1 and 2 will come at the end. So we have done left rotation. If it would have been right rotation, things would have happened in another way. Now, this is how rotation is done, and we know now that what is left rotation or rotation of an array. Let's take one more example. Let's say I would rotate it for 4 places. In that case, what would happen? 5 and 6 would come here, and here we will have 1, 2, 3 and 4. So just think of this as a closed array if you are getting confused. So if this is 1, 2, 3, 4, 5, what you have to do is, let's say this is the end. This is the end. What you simply have to do is you have to shift everyone to 2 places. If you are rotating by 2 places, shift everyone to 2 places and then open the array. So if you shift everyone to 2 places, what will happen? We will have 5 here, 4 here, 3 here, 2 here and 1 here. So now if I open it from here, what will I get? I'll get 5, 4, 3, 2, 1. So this is how the rotation happens. Now there are various ways in which we can do the implementation of rotating an array. So let's see what are the various ways in which we can write code to rotate an array. So we will see various approaches to rotate an array. We'll start from the easy approach. When I'm saying easy approach, which means that approach is easy to code, but somewhere it has more space complexity or time complexity, and eventually we will go on to optimize the time and space. So the very first approach that comes in mind is that what we can do is we can take help of a temporary array. So what we have to do is, if we have to rotate this by 2 places, so we somehow have to bring these 4 elements at these 4 places, and these 2 should come at these places. So what I'll do is I'll take help of a temp array. So I will store 1 and 2 in this temp array. So now I have 1 and 2 stored in this temp array. So now this value is safe with me. Now what I will do is I'll shift all of these to their original places. So we are shifting by 2, right? So we are rotating by 2. So everything has to be shifted 2 positions. So now what will happen? Our array will look something like this. We'll have 3, 4, 5 and 6. So now what we have done is we have copied the 2 elements here. If the d would have been 3, let's say the rotation is done by d places, and we have n elements in the array. So if the d would have been 3, we would have copied 3 elements here. If it would have been 4, we would have copied 4 elements here. So right now we have just 2 places. We have to rotate the array by 2 places, so we have just copied 2 elements. After I copied these 2 elements, I shift everyone 2 places to the left. Now everyone is here 2 places to the left. I have made place for 1 and 2. So I will simply copy 1 here and I'll copy 2 here. So if you see in this particular case, what will be the time complexity and what will be the space complexity? So the space complexity, as we can see, is O of d, and time complexity is O of n plus O of d. So what are the operations we are doing? First, we are copying these 2 elements here. So here the time complexity becomes O of d, and then we are shifting these 4 elements plus copying back these elements, which corresponds to O of n. So our time complexity becomes O of n plus O of d, right? and the space complexity is also O of D. So before we go on to see another approach in which maybe we do not need this much of space, extra space, let's see how do we implement this particular thing. We'll just write the loop for this. So what I will do is I'll take an temp array, I'll copy elements from I equal to 0 to I less than t from array, let's say this is air, from air, from air to temp. So temp of I is equal to air of I. So now this thing has been done, this particular array is created. Now we have to shift all the elements 2 places to the left. What we can do is we'll again run a loop for I equal to 0 till I less than n minus d minus 1, because we have to do this particular shifting only till this particular place. So we have I plus plus, and what we'll do is our air of I will be equivalent to air of I plus d. So what we have to do is we have to do the shifting by d places. So this particular statement takes care of that. Now after this particular loop gets executed, we have shifted these 4 elements. Now we have to copy back these 2 elements. So what we will do is we'll do for I equal to n minus d minus 1, I less than n, I plus plus, and we also need one more variable j equal to 0. Let's say what we do is air of I is equivalent to air of j plus plus. So what will happen that this j goes from 0 to d minus 1, and all the elements from this temp array is copied to this particular place. So this is how we can write code to rotate an array in which we are taking some extra space, we are copying the elements to that extra space, and then we are doing the shifting and then copying back that element to this original array. Now let's go ahead and see some another approach. So we do air of I is equivalent to temp of j plus plus. So this particular thing ensures that these elements are copied back to this particular array, and hence this array is the rotated array. Now let's go ahead and see another approach for rotating the array. Now let's see another approach for array rotation. So in this approach, what we will do is we'll try and save space. What we did in previous approach was that we were copying some part of the array into a new array. So we will try and avoid that thing. So how we can do that? So another approach that we have is, what we can do is we can rotate the array one by one. Okay, now let's see what does that mean. So let's say I have to rotate the array by 3. So I won't go on to directly rotate the array by 3. I'll rotate the array by 1 first. So when I rotate the array by 1, how does my array look? So my array will look something like this. We'll have 2, 3, 4, 5, 6, 1. Okay, so now what I'll do is I'll again rotate this array by 1. So now my array will look 3, 4, 5, 6, 1 in 2. And what I'll do next is that I'll again rotate the array by 1. So we'll have 4, 5, 6, 1, 2 and 3. So as you can see, finally I have got the same result which would have come if we would have rotated the array by 3 times. So this is equivalent to rotating the array by 3. So what we have done is we rotated the array by 1, and how many times we did the process of rotating the array by 1? We did it for 3 times. So the approach that we're talking about here, what happens in this is that we rotate the array one by one, and this one by one rotation happens for d times. Now, how do we rotate the array one by one? Let's see the code for this, or for that matter, first let's see the procedure. So what we will do is we will take out this particular first element and store that in a temp variable, and then what we will do is we'll shift all the elements to the left by 1 position, and at the end I'll put this temp at the end. So what we have done here is, in this particular process, in this particular sequence, we have 1, taken 1 as temp. Now I have rotated 2 for 1 position. I have shifted 2 by 1 position, shifted 3 by 1 position, 4 by 1 position, 5 by 1 position, 6 by 1 position, and at the end we have 1 position where I am going to put back this temp. So I am going to put back 1 here. Again we are doing the same thing. We have 3 stored in temp. Sorry, it's going to be 2 stored in temp. And again I am rotating or shifting 3 here by 1 position, 4 by 1 position, 5 by 1 position, 6 by 1 position, 1 by 1 position, and then I'm putting 2 at the end. And similar thing we did it here. So every time we're storing the first variable in a temporary variable or first value in a temporary variable, and I'm shifting rest of the element by 1, and at the end what we are doing is we are putting this temp back. So now let's see how can we write code for it. So the very first thing we'll do is, let's say we have to rotate the array by 1. How will we do that? So we will have a temp variable. So let's say this array is arr. So what I'll do is we'll have for I equal to 0, I less than n minus 1, I plus plus. I'll shift all the elements to the left by 1 position, and even before I do that, I'll store the first element in the temp variable, and then we'll do the shifting. How we will do the shifting? Arr of I is equivalent to arr of I plus 1. So after this particular loop is complete, in this case our array will look something like this. So after this particular line, our array will look something like this. We'll have 2, 3, 4, 5, 6 and 6. So since this loop is running only till n minus 1, so we will have values shifted till here, and what we will do is, after this particular thing has happened, we will update our arr of n minus 1 to temp. So after this particular operation, what will happen? This 6 will become 1. So this is just one rotation, and we know that we have to do this rotation at least d number of times. We have to do this rotation d times. So let's say I put this complete thing inside a function called rotate. So what we will do is we'll run a loop d number of times, and I will call this particular function d number of times. So what happens is that this particular loop run d number of times, as this is a complete function. We have seen this is a complete function, and this is called d number of times, and hence this rotation will happen. So if we see the time and space complexity, the space complexity is constant since we are using just particular variable. So it is O of 1. And the time complexity, if we see that the time taken to run this particular loop is O of n, and this particular loop will run how many times? As I said, that we'll call this rotate function at least d number of times. So the total number of times loop run is n into d. So total time taken will be O of n into d. Now this is how we can rotate the array one by one. In this case, we are not taking much extra space or any extra space, but our time complexity has increased from O of n to O of n into d. Let's see if we can improve this using further approaches. Now we will see another approach for rotating an array. This approach is also known as reversal algorithm for array rotation. Now let's see why is it known as reversal algorithm. So what we do in this case is that, let's say I have to rotate the array by d. In that case, I'll divide the array in two parts. One is n minus d and another is d. And this is not an actual division. It's not that we are doing something like we are making two separate arrays, two separate new arrays. We just have this particular array only. It's just that, let's say we have first array from index 0 to n minus d minus 1 and another from n minus d to n minus 1. So you can think of it as a virtual line over here. Okay, so now let's say I have this two particular part of the array. What I will do is I'll reverse both the part individually. Make sure I'm saying reverse. So I'll reverse this part and this part individually. So when I reverse this part, let's see what happens. We get something like 4, 3, 2 and 1, and when I reverse this particular part, we get 6 and 5. So now this was n minus d and this was d. Now what I do is I'll reverse the complete array. So when I reverse the complete array, what do I get? We have 5, 6, 1, 2, 3, 4. So if you can see that this is the rotated array and how I wanted my array to be. So if I wanted to rotate this array by 2 times, this is how it would look like. So what I did, I'll just repeat. We divided the array in 2 parts. One was n minus d and d. That was not the actual division. It's just that we were taking care of the index. And then we reversed the first part and the second part individually, and then I reversed the complete array. So now if I have to implement it, the only thing that you need to know is that how do you reverse an array? And we have seen this multiple number of times. So rather than going on this, let's see that how do we call the reverse operation again and again. So let's say we have reverse operation and it accepts start index and end index. So what I'll do is I'll call reverse with index 0, n minus d minus 1. This is for this particular part, reversing this particular part. And then we call reverse n minus d, n minus 1. This is for this particular part. And then I'll call reverse on the complete array, 0 to n minus 1. So this particular call reverses this part of the array, this particular call reverses this part of the array, and this particular call reverses the complete array. And hence we get the rotated array. Now if we see the time complexity to reverse this part is O of n minus d plus O of d for this part plus O of n. So this is actually equivalent to O of n plus O of n. Hence, we can say that time complexity is going to be O of n. So time complexity is O of n and it is not taking any extra space. So space complexity is constant. So this is how reversal algorithm works for rotating an array.